Hello and welcome to Stars, Cells, and God, the show where we discuss new discoveries taking place at the frontiers of science that have theological and philosophical implications, as well as new discoveries that point to the reality of God's existence. My name is Hugh Ross, and I'm joined with Jeff Zweerink, and today we'll be exploring two topics, two new discoveries. But before we get into the discussion, I wanted to encourage you to subscribe to our channel, Reasons to Believe, our YouTube channel, so that you can be notified of our new weekly videos. Learn more at reasons.org or by following us on social media at RTB_official. Well, Jeff, tell us about the discovery you've been so excited about.
Well, one of the things that I have been paying quite a bit of attention to lately and have always been kind of fascinated with is just the topic of artificial intelligence and computers and what can they do. I know you're a chess player, and I remember back in the 90s, there was a lot of discussion about can we build a computer or a machine that will beat humans at chess? And there was a lot of back and forth about that. And I remember I'm pretty sure it was 1996 where they had the Deep Blue and Garry Kasparov were having a battle, and Kasparov came out victorious. But the next year, the machine finally won. And I remember thinking, it's like we've lost something. There's something gone there. But what struck me is that there's this sense that if a computer could play chess, well, then it's got some sort of intelligence similar to what humanity has. And in the meantime, since that has happened, again, that was 25 plus years ago now, basically any of the chess programs out there are so much better than humans. They actually have to throttle them down,
right,
so that we can play with them.
Exactly.
It's just they're so much better that we can't even compete. In other words, they're superhuman in their ability to do things. Well, I've seen just a proliferation of areas where AIs have gotten better than humans in a number of ways. Chess is one.
The game Go, I think, was
Go,
recent.
yeah. In fact, I don't know that on Stars, Cells, and God, but on a previous set of podcasts we've done, talked about AlphaGo, which could play Go and Shogi and chess. And in all three, it was better than humans. And it was kind of one of the first AIs where it could do multiple things like that better than humans. And what struck me, though, or what I found fascinating, is it wasn't like it learned how to play chess and it said, all right, given what I've learned there, how do I apply those principles to playing Go? Or it basically relearned how to play each one from scratch. So it's kind of a more capable, but also not quite the same level. It's not the way humans approach it, if you will.
Right.
Well, since that time, AIs have gotten better at numerous things. It can play poker better than humans.
It can navigate better.
Well, it certainly navigates very well.
Yeah.
I'm not sure that it navigates better. It just has more data to process than humans. But that things that we used to think were entirely in the human domain, we're now starting to see kind of a proliferation of AIs that can do things that were human. And so I thought three interesting places where AIs have achieved human level, maybe not beyond human level yet, but certainly high-end human level, were three papers that I looked at. That one was learning how to play Stratego. And, Stratego is this game where you've got, I think it's 40 pieces on a board, and you've got, ones and eights, or I think it's up to 8 or 9, and there's bombs and generals, and, you kind of move around the board, and the idea is to figure out where your opponent's pieces are, find their flag, and take their flag. And if you attack somebody who's got a higher rank than you or a more powerful rank, your piece gets taken off the board. And so, I remember playing that when I was in middle school. My cousin had a game of it, and it was an interesting game, but it is one of those games that AIs have learned how to play and play as well or are actually much better than humans. And so that's one game. The other game that I found very fascinating was a game called Diplomacy. I don't know if you've ever played Diplomacy. I've never heard about it until today, or until I was reading this article, not today. But this is a very interesting game because, games like Risk, where the goal is world domination, if you will. You start out, you place your army certain places, But all of the battles and all of the advancement is done turn by turn. So I take a turn, you take a turn, you go around the table. And the battles are, I'm going to attack, and you roll dice and see who wins. Well, diplomacy is a very different game than that. It's actually all verbal or communication, if you will. So in the way diplomacy is set up, there are 7 people who play, or it's designed for 7 players. You see there on the image at the right, it's kind of set in Europe, and there are a number of different regions you can own. You can own armies, you can own fleets, and they can move different ways. There's certain rules for how they can move around. And what you do is you talk with one another and talk strategy, and you can talk privately or you can talk openly. You can make rules about how you do all that. And then so you do your negotiations, and then everybody's play happens at the same time. And there's somebody who mediates all of the conflicts that would go on with that. And what's interesting about how the game is played is that it's a very communication type game. So it's not like chess. You never have to say a word. It's like these things can move this way and that's all you know. It doesn't require any communication. Diplomacy is built on being able to communicate. So you and I are going to talk. We're going to negotiate things. I may say something. I may be being deceptive. I may be being truthful. I may seek to form an alliance. I may betray you later. The AI has learned how to read the I'll put read in quotes, to process the communication, to generate the communication and play this game better than the average player. In fact, it's in the top 10% of players, this AI that's doing that. And what I find fascinating about that, or the intriguing part about that, is that it's not a, here are the rules, go play. It's very much a communication game. And the AI is capable of interacting with all of the communications, both hearing and understanding, if you will, and then generating communication to do things. And it can play this game as well as or better than most humans.
Well, especially if you got lots of players, because basically I presume it's using game theory to figure out how to negotiate. But if you got lots of parties negotiating, I can see where the AI would have a big advantage.
Well, that's just it. There's only it's no more than 7 people play at a time.
Okay.
And again, it's there's always strategy in there, and there's game theory that goes on. But what I think is remarkable about this is that it's done at the level of communicating. How do you teach an AI to, without the kind of emotional interpersonal skills that people bring into that game, or into that activity, if you will, an AI has to be able to, based on all the words, and doesn't get level of emotions and voices going up and down. It doesn't process all that, but yet it can figure out what's going on and communicate well enough to play as well as better than humans. And even more remarkable in my assessment is another AI that is it can actually write computer code. And so this is a program called AlphaCode, similar sort of name to AlphaGo, if you will. But it will, just given a prompt, it's got to be able to read and understand the prompt and then generate code. And I've just got to thinking about these. It's like AIs are increasingly encroaching on things that seem to be unique or humans are exceptional at doing. We communicate in a way unlike any other creatures. And here you got AIs that are playing that communication game and doing it as well as we are. Being able to write computer code, that's a very symbolic, high-level task. And here you've got AIs that are writing computer code at the high end of what humans are able to do. You've got AIs that can generate songs and sing and compose and record them. You've got AIs that can generate art. You've got AIs that can generate essays and articles and poems. In fact, I was just doing an interview the other day, and somebody had asked ChatGPT to write a poem about me, and so it had written a poem about Jeff Zweerink. And it makes you feel far better than it makes you feel far more than what. Be careful not to get a big head, I guess. But
did you like the poem?
It was a pretty fascinating poem, I got to say. It was pretty cool. but we've got these AIs that are encroaching, if you will, on things that are unique, what seem to be uniquely human behavior, and they're doing it as well as, and probably will be able to do it much better than humans. And so that to me raises the question, what do we do, or how do we think about all this? And part of my thinking about it is that a lot of things play into AI, but I think if AIs start to do human level activities better than humans, question is, how do we determine value? And, if, like I said, if AIs can, I suspect at some point in time, AIs will learn how to do science, if you will, and can contribute and build the body of knowledge in science and compose music and all of these things that humans do that we're at the top of the pyramid, if you will, AIs will do better than us. So what does that say about the value of humans? And what does it say about the work? Because, I don't know if you've ever played around with ChatGPT, but I could very easily see a person like myself saying, you know what, I can have it write articles, I can have it answer questions. All of the written communication that I do could be generated by ChatGPT. So what am I doing here? I mean, what outside of providing the prompts to get it done, why am I here? What's the value in the work that I'm doing here? And it struck me that Genesis or Scripture talks a lot about this. And I was kind of drawn to Genesis 1:26 and 27. It says, "Then God said, 'Let us make mankind in our image, according to our likeness, and let them rule over the fish of the sea, over the birds of the sky, over the livestock, and over all the earth, and over every crawling thing that crawls on the earth.' So God created man in his own image. In the image of God, he created him, male and female, he created them." And two things stood out to me about that. One is that our value comes from being created in God's image. So whether AIs ever do the things that humans can do, even if they do all the stuff that we can do better, humans are inherently valued because we're created in God's image. And that means that every human is valuable because every human is created in God's image. But it's also in this description, God not only creates us in his image, but he immediately assigns tasks for us to do. He wants us to work. He's designed us to work. And so as we're dealing with AIs, it seems that it's very important that we keep ever present in our mind, does the things that we're doing with AI, do they enhance our understanding of human value? Do they contribute or do they diminish that? And do they contribute to humans having meaningful work, or do they take that away? Because a lot of the things the AIs can do are taking away the jobs that are what we would consider, I'm not going to use this pejoratively. I'm not sure how to say it. They take away the jobs that are a little bit easier to do, which means there's a whole lot of people there's a particular class, or that means that there are people who maybe they can't do science, but they can push a broom or they can hammer a nail or whatever. Those are the types of jobs that AI is going to take away. And so we need to be careful how we're thinking to make sure that people have, one, recognize their value because of being made in God's image, but two, have worthwhile and valuable work to do because that's the way God's designed us. And so I think this is just a reminder to me of how much your worldview anchors or determines what are those important things. And if we don't have a good worldview, AI is going to cause a lot of problems for a lot of people.
Well, I kind of take a more positive, optimistic view on this. I mean, I look at this passage you got here, and it's like it's really challenging for us humans to fulfill God's mandate. You're in charge of the planet and its resources, manage it for your benefit and the benefit of all life. We need AI to be able to do a better job of that, because with AI, we can actually inventory all the resources. It's hard for any human to do that, because the wonderful thing about AI is its memory. It can store things, and it doesn't forget.
Right? No, you're correct.
So this can really assist us in better managing the planet, because we're going to have more complete data. The data is going to be more trustworthy. I mean, you used the example about this game of diplomacy. I can easily see somebody writing software saying, let's actually throw into memory the intonations of people's speech and kind of figure out so that the AI software can determine this intonation means X, this intonation means Y. And so we're actually going to have AI machines that are actually going to be able to emulate fairly faithfully the emotional context of human communication.
No, I wholeheartedly agree. And I do. I see two mindsets about AI. One is, ooh, this is awful, we can't do this. And I think that's a wrong way to look at it. But there's another, it's like, oh, this is so great, we just have to do it.
Right.
And both of them miss that this is a tool.
It's a tool,
and
exactly.
The bigger the tool, the greater good you can do and the more damage you can do, depending on how you wield it. And how we wield it is going to be determined by how we think about things. And, if I'm honest, my tendency is on the little more, let's hold back, let's be a little careful, maybe this isn't the greatest idea. I think in large part because I see the ways that humanity's going to abuse it. The more realistic our AIs get, the more people are going to substitute AI relationships for human relationships.
It's already happening.
It is,
People
you're
are
right.
building AI sex robots.
You're
so
right.
It's like we're already in this new world. And so, yes, like with any tool that we humans invent, realize it can be used for good, it can be used for evil. And, we're in charge of the planet, and we're in charge to rule it in a righteous way. So let's make sure that we use AI in a way that achieves God's mandate.
Yeah.
And also, I think we can use AI to restrain evil. I mean, we're already seeing that. The fact that, we've got these cameras all over the place, so we can actually document when crimes are being committed. And so it's a tool that the law enforcement can use, but it's also a tool that we see in China where they're saying, we're going to monitor you to such a degree that we're going to be able to control your behavior in ways that you don't like. So
or even worse, it's being used to execute genocides in certain countries because the same technology that allows you to find the criminals allows you to find anybody.
Exactly.
And that's one of the things that I've found is that in all the different AI advancements, and they're pretty spectacular what they can do. For every for everything you can see, ooh, here's good that can be done. It's like there's an equally bad, awful thing that can be done. The same AI that can develop drugs to aid in cancer research just by toggling a flag can be used to build bioweapons. It's a really powerful tool, and that's where I think what I find really encouraging is that as a Christian, when I look at the worldview that Christianity brings and what it says about people and what it says about how, that there's this greatness in humanity and this depravity in humanity, that AI is not the solution, nor is it the problem. It's a tool. Humanity is the solution or the problem. If we use it the way God intended and do the things that build what God intended, we are doing what God's asked us to do and take dominion and rule well. And if we abdicate that or choose to use it for nefarious purposes, we're going to cause great damage. Christianity gets that and realizes that Christianity is not just, here's a set of rules. It's here, Christ owns you, become like him. You're a new creature. It gives you the capacity to do what he set us out to do. So I think the question of whether AI is good or bad misses the point. Humans can be good or bad, but it's a powerful tool. Let's think about it well so that we use it well.
Yeah, in the context of this passage too, we're going to be able to, fulfill this mandate. We have to find a way to free people of labor. And in one sense...
what do you mean by that? Because there's part of that I would see that God has, by doing this, he's given us labor to do.
Right. But a lot more labor than we got the manpower to fulfill. And therefore, I think God all along intended that we would pursue technology to save labor that we can devote to more important purposes. And in one sense, this has always been around. I mean, you're a young man, but I remember when you had to have an elevator operator in all the elevators in the country. And so we developed a very simple AI system where elevators could run themselves without having an elevator operator.
Yeah.
And what did it do? It set free all that labor. We didn't have to employ people to run elevators anymore. They could do more significant work. And in one sense, I'm looking forward to the day when we can use AI where we can eliminate all the truck drivers in the world. I mean, you think of how many millions of truck drivers we have here in America. They're sitting behind the wheel of a truck. What if we could set them free to do more significant labor and have AI drive all the trucks and maybe even reach a point where AI can load and unload the trucks as well? Look at the huge labor saving we would have. And
But I mean, on the flip side of that, I am pretty good, very good at math and science type things. I have a mind that operates that way. I have run across people and have come to appreciate, I've worked in factories, worked with other people who are in construction. There is a mind they have to do that. It looks like it's menial labor, if you will. But I just remember when I was in college, I worked at a truck manufacturing plant. Now, I'm a pretty hard worker, and I would go in and we'd build these things called outriggers, you know, the things that go out, sit on the ground, and keep the trucks balanced as they have their aerial devices work. And there was a goal of, you know, each one took so much amount of time. And so I was supposed to build a set of 6 of these in a day because each was about an hour and a half and we had a 9-hour day. And I would go in and I would work hard, and I was pretty good. And I could do it a little faster than that more times than not. And I'd look over at my colleague who was the guy who trained me and had been working there many years. And for all I could tell, he sat around and talked all day and didn't seem to work. And I watched over time, and what I recognized is here I am working, I'm dirty, greasy, whatever. He comes out clean, and he still produces as much as I had. That it seems like that God has designed people that just know how to do those sorts of things. So I don't know that elevator operator is a God-given employee, if you will. But I do think there are people who are designed and who enjoy and really excel at mechanical tasks. And I worry that, or I'm concerned that we look at that and say, well, if we get rid of the mechanical task, it allows them to do something else. But you could easily say, well, get rid of all of the science, so now you can go out and do something more. You're getting away, or you're getting rid of the thing that God has designed you to do in some sense.
yeah, but there's always more to do. And it's like I look at this mandate saying, you know, in the context of Adam and Eve, it looked like an impossible mandate. And God said, well, you're not doing this by yourself. Be fruitful and multiply. Mm-hmm. It's going to take a lot of people to be able to take this out. It's also going to take significant technology. And my whole point is some level of AI has always been with us. And in one respect, it's enabled us to fulfill a task we otherwise couldn't do simply because we don't have enough man hours. So, and I think that's going to continue. And I think that's the non-controversial part of AI. Using AI to enable us to do more work is a good thing. Mm-hmm. And then we got the other thing of, well, you know, it could be abused. It could be used for good. So,
well, and that's where I think, again, you know, one of the things that I'm coming to appreciate is that Christianity is not just true in the sense that it accurately describes the world and, you know, what we find in science aligns with what we find in the Bible where it talks about things. But Christianity provides the worldview or a way of looking at the world, whatever terminology you want to use for that. It provides a way of looking at things so that we can use AI well, and it mitigates a lot of the harm that would come. If we live and become the kind of people that Christ desires and has created us to be, we will use AI well. And if we don't, we're going to use AI poorly. And so this is a place where we can advocate that not only is Christianity true, but it's good.
right.
And I think that's a fascinating discovery. So
Yeah,
I'll kind of wrap up there. I know you've got some stuff related to this that may be AI helpful. And so,
Well, you know, in the book Weathering Climate Change, I talked about one of the ways that we can mitigate climate change and global warming is by changing the way we harvest timber in forests. And, you know, just talked about how, you know, young trees grow faster than old trees. Mm-hmm. And if you let the old trees die, they decay and release greenhouse gases to the atmosphere. We'd be wiser to harvest those old trees before they get sick and begin to die. And if we harvest them and turn them into furniture and buildings, that sequesters a lot of carbon. Replace those old trees with young trees that grow 2 to 4 times faster, that's going to enhance the amount of greenhouse gases pulled out of the atmosphere. What encouraged me is a study done in Malaysian Borneo, where they basically affirmed all this, that selectively harvesting not all the old trees, because you need a few tall old trees to sustain the ecosystem.
Okay.
But harvest the ones that are about to die.
Okay.
And that's where you make the most money in lumbering anyway. You know, those big old trees.
Biggest and strongest kind of thing.
Exactly. Yeah. I mean, that's where the money is to be made. And by replacing those older trees with younger trees, you will, make more lumbering money, and you'll pull more greenhouse gas to the atmosphere. But it was a group of research science international team went into Malaysian Borneo and tried to determine what does it do for the ecosystem.
Okay.
I mean, as we harvest these old trees and replace them with young trees, is that going to debilitate the ecosystem or enhance the ecosystem? So what they did is they looked at 4 different forests that were old growth forests that had never been logged.
Okay.
And they contrasted that, it was 5 old growth forests, and they contrasted that with 4 forests where they were doing this, what I would call green logging, not clear cutting, where they cut everything, but they go into the forest and selectively harvest trees and replant young trees to replace the trees that they harvest. And so they looked at 4 of those.
Just to get a scale, clear cutting, you go in and you just cut everything. And so you could see, given how many trees, you can calculate how many there are. The other extreme of that is never touch anything, just let it all grow.
Right.
So somewhere between 0 cutting and 100% cutting, when you're talking about this green harvesting, are we 10%, 50, 90, 100, what?
Well, what we're talking about is the amount of land that's covered by forests remains the same.
Okay.
You're basically selectively cutting out trees and replacing those with new trees.
Gotcha. So do you have do they describe in there or give any sort of sense of how much of what the forest is there? I mean, I could see where you're just taking like 1 or 2 trees, which is really close to not logging at all, or you could be taking almost all of them, just leaving a few around. And I don't have any sense of how much is being done.
Well, there's no net deforestation going on.
Okay.
So the land area remains the same. But what is happening is you're pulling out some of these older trees,
Okay.
and that creates some space.
Okay.
Because it takes a while for the young trees that you put in there to actually grow and replace the old trees. So it does create, basically eliminating some of the canopy. And this is where they discovered, hey, there's an ecological benefit to this. Because now parts of the forest, you got a very heavy, tall canopy. Other parts, you have less. But it's still completely forested.
Right.
And they contrasted that again with forests that they never log at all.
Okay.
And then they put one more sample in, which was a clear-cut forest that they replaced with an oil palm plantation.
Okay.
So that was kind of their little test site. So they had one of those, 5 that were untouched, and 4 that were logged.
All right.
And then they measured the energetics. This is the first study ever done where they actually looked at the energetics of plants and animals. And actually how much photosynthetic activity is going on from trees and plants, and then how much food is being consumed by birds, by mammals, by insects. They actually looked at bats.
I'm curious, how do you measure that? Because it's not like you can put a bunch of detectors out there and do it.
I asked the same question. When I looked at the abstract, I said, how did they pull this off? Well, when I read the paper, I said, gee, they came up with some really sophisticated ways to do this.
Okay.
Number one, they placed 892 automatic cameras throughout the 10 different plots. And these are cameras that automatically take photos when an animal walks by.
Okay.
So they get an idea of, what kind of animals, what the population of animals are, what their body sizes are.
Right.
So if they do that over several months, they get a lot of data.
Okay. All right.
That was part of it. The other thing is they went in and they measured tree diameters. So they're basically counting the tree rings. And I think they did
So this has got to be a multi-year study.
study. They did 20,000 measures of tree diameters.
Okay.
So that's a lot of data. And then they also looked at the fine root system. So they went below the soil and began to look at the little fine roots that come off the big roots.
Right.
And took samples there measuring the activity that's going on. And they did 2,700 of those. And then they captured bats and birds and insects. So they went in and at 508 sites, they counted birds. And they also looked at litter fall, how much leaf is coming down.
Okay.
So they had 14,000 litter fall measurements. And this is what it actually takes to actually get an accurate measure of the energetics. I mean, if you just walk in there and try to observe, I mean, it's totally subjective. And their whole point is we want an objective measurement on the energetics of the plants, the trees, the birds, the mammals, the insects. And so, and what they discovered is that when you looked at the logged forests, the forests that were selectively logged in a way that was economic, but also sustained the forests, is that the consumption of food by birds and mammals was 2.5 times greater than what you saw in the forests that weren't logged at all. So,
that's pretty remarkable. That's a lot.
That's a lot. And then they were looking at, okay.
Well, and I'm assuming they're looking at things that measure the whole cycle. So, I mean, you've got obviously animals eating stuff. That's one level, but you've got to have something that replaces the nutrients. So seems like just the energy consumption of the entire ecosystem is what went up.
Yes, the entire that they did document that. And then they're also looking at, what's going on. A factor 2.5 times is not small.
Right.
So there's got to be some cause here. And what they identified is by taking out some of the old big trees, it actually allows more sunlight to come down into the forest.
Right.
And then you've got the younger trees growing, and the younger trees do not develop the herbivore defenses that the older trees have, which means that the birds and mammals are able to consume a lot more.
Okay.
Because the plants and the trees haven't had time to build the defenses.
Right.
And the biggest threat to trees and plants are insects. And so they noticed that the insect population went up, but what that developed was the bird population skyrocketed. Because now birds have got insects to eat. And so there was this incredible balance where the insect population went up because they had more to eat, but the birds were able to eat the insects, which actually helped control the herbivore attacks on the plants and the trees. Because the birds are basically taking out the consumers.
So it seems like they'd have to take a fair fraction of the trees out for that to be, if you're talking about sunlight.
We're not talking just logging 1 or 2 trees.
Okay, so it is a pretty, one of my questions I had in that, what's going on there, the best listening to your description is that the amount of wood you get out is driven by what the forest can sustain. And you can go one and say, well, we're not going to do any. That doesn't reach an optimal level. You do too much, that's also beyond the optimal level. You kind of have to understand the forest well enough to know what can and can't be taken out to keep it.
Well, that's what was interesting about this study is that, these commercial lumbering companies, they basically figured it out.
Oh, yeah?
In the sense that, we want the forest to be sustained, no net deforestation, but they're able to determine what's the maximum amount of timber we can take out and not result in deforestation.
Right.
And that's where you make the most money in terms of lumbering. But what they also determine, that's where you benefit the ecosystem the most.
Interesting.
Is when you hit that maximal lumbering limit, and they determine what's really going on in the forests that are not being logged. You've got this very high, thick canopy. The forests that are being logged, you got variable canopy. You got the high canopy, but you also got lower canopy.
Right.
And so it allows for a greater variety of plants. So the plant diversity, the tree diversity goes up, which also causes the animal diversity to go up. And so everything, it's basically win-win. The lumbering companies are happy because they're making the most money, and you're actually getting the greatest diversity of plants. You're getting the greatest biomass. And then they looked at the oil palm plantations.
Right.
And they had abysmal results there in terms of what was happening with the ecosystem. And what they discovered is what's happening in the oil palm plantation, you got a low canopy and no high canopy.
Yeah.
And basically,
well, you've taken away all the diversity, and
right,
at the very minimum, you've done that.
Yeah,
so.
I mean, you're only growing one kind of tree, which is the oil palm, but they're all the same height.
Right.
And so there's no variety in tree height, and that limits the variety of animals and plants that can coexist with the oil palms. And so they saw this huge benefit with the sustainably logged forest, and they saw an abysmal result with the oil palm plantation.
Right.
And so the bottom line is you want to manage a forest in such a way that you've got variable canopy, which actually allows for the greater biodiversity and biomass.
Mm-hmm.
And this was done in Borneo. And basically, it's a principle that could be applied worldwide to all forests.
Yeah, well, I mean, each forest or different forests are going to be different. But, you know, it reminds me of how sometimes we have to be careful because well-intentioned policies or well-intentioned ideas could have kind of bad effects. You know, I think of for a long time we said, hey, we're just not going to let fires grow because fires have to be bad. It's like we didn't understand the ecosystem, and as a result, we did something that was or it didn't allow the ecosystem to thrive as well as it could. If we log too much, you got a problem with the ecosystem. But if you don't log enough, you have a problem with the ecosystem as well.
And kind of the key point of this paper is if you want to wisely manage not just the forests of the world, but the grasslands and pastures, and you need to study the energetics. You know, simply, you know, doing your best to count birds and things. No, they said energetics is the key to wise eco-management. It's also the key to enhancing the economic benefits. And this could even be applied in the oceans.
So how do you think AI will help us do this better?
Oh, very good. No,
no, because it's a big task to get the data, if nothing else. So,
well, I mean, one of my cousins, I was sharing with you yesterday, he would be dropped off on a helicopter in a Canadian forest, and he'd be given a couple of weeks to try to estimate the number of board feet that could be harvested of all the different timbers. I mean, you could use this kind of technique with the cameras, taking the samples, and using a sophisticated AI system to be able to do that job a lot more accurately and a lot more rapidly. And, you know, it's expensive dropping in trained forest management people with helicopters and all these different things. What if you just set up all these cameras that took all these measurements? And you could do this not just in one forest, but forests all over the world, the oceans. But to make that work, you're going to need a sophisticated AI system to be able to handle all the data that needs to be processed. Because that was a big problem with this, is I mentioned all the sampling they took.
That's a lot of data.
I mean, one guy can't just sit behind with a notepad and try to determine what's going on.
Yeah.
You need to write software to be able to take in all this data and draw the appropriate conclusions. And that's why they had a computer programmer as part of the research team.
Well, that's what's one of the things that struck me in my research when I started doing gamma ray astronomy is there are certain fields where you can take photographs or plates or whatever and sit down and count. And just the amount of data we had coming in, I mean, it was small compared to what we do today. It was it's small, but I mean, we had, you know, hundreds of data points 10 times a second. You just can't sit and do the calculations because the calculations on those are fairly extensive for each one. You got to have computers to do that. What I wonder, and one of the things I think we need to watch as we develop the AI is that at least with that sort of thing, yes, I'm using the computers to do that, but we still know what the computers are doing. Very often when you're dealing with AI thus far, it may find things and tell you stuff, but it's hard to know what it's actually doing. And so I think that's something I know AI researchers are working on, but we need to make sure we understand what's going on, or else we got this AI telling us what to do, but no way to query whether is that really what's best, or did you miss this, or whatever. So,
well, the more complicated the software, the more difficult it is to control it. So
that's true too. So.
Yeah. Okay. Takes me back to my graduate school days, Jeff, because I got a call from the university president. And he says, we've been looking at the computer and realized there was one guy that was using 25% of the resources of the university computing system. Had no idea who it was.
Oh, yeah.
Turned out it was me.
Nice.
So I said, what are you doing? So I told them. They said, okay, as long as you keep doing it in the graveyard hours, we're okay with it.
All right. Now that's funny.
But, compared to today, I mean, what I was doing was a pittance
Oh, yeah.
compared to what we can do today. Yeah.
That is definitely true.
Well, thanks, Jeff. This has been good. I want to thank all of you for joining us today on Stars, Cells, and God. Join the discussion in the comments below. And remember to like this video and to subscribe for more content. New episodes of Stars, Cells, and God release each Thursday and are available here on YouTube and on your favorite podcast app. Be sure to share this video with a friend, and remember, the more we know about science, the more reasons we have to believe in Jesus Christ as Creator, Lord, and Savior. Thank you.